Hi all. In this video, we are going to see a paper titled "Rich Futures for Accurate Object Detections and Semantic Segmentations." It is based on a famous paper normally called as RCNN. So this paper starts with a beautiful sentence that futures matters. Yes, for the past decades or 2 decades during that time, like 2014, most of the effort have been put up on how to extract enough futures for object detections or image classifications. Yes, it is one of the big challenges because we have pixel data which is spatially pixel data or grayscale image or RGB image, but how to take like an enough features, maybe global features or local features. So most of the attempts have been based on that. Once the image like a human based logical thinking in their mind how to extract the features, like bring brought about algorithms like shift or hop, so that some kind of enough rich invariant features were taken, irrespective of variance in illuminations and poses and cluttered background. And in related to the classification side, most of the effort have been put up on employing ensemble systems, and there were minor improvements here and there on those ensemble systems, like modifying the data boost or modifying the SVM. All those techniques were being adapted until this paper. So this paper claimed that this rich features computed from the human based mathematical logic were very much related to first cortical uh, area in the primal visual cortex. But usually in the empirical data from the cognitive science or neuroscience says that there might be some kind of a hierarchical way of representations or multi-stage process to compute enough features so that human eye can identify what is in that particular image or what is in front of that humans. So people inspired based on this put up different architecture. One is neocognitron during 80s, and another one paper is from Leaken's convolutional neural networks. But those were not become very established or promising state of the art for many limitations in how to train or how to fix those parameters. So it was only in 2012 like AlexNet was brought up for successfully applied to ImageNet and beat many of the standard algorithms based on the conventional method, like SIP-HOG is a linear SVM classifiers. So, but the big question arises in around the workshop around 2012 is how this could be adapted for the object detection instead of image classifications. So that's what this paper address about. This paper is the first paper claimed in this that they have made an attempt to adapt CNN based on that AlexNet in completely bypassing the hog-like features for the object detection. So it has focused on two problems. One is image localization, that is object detections or object segmentations using uh, convolutional neural networks. So previously, this that object detections in an image at anywhere in the positions were based on a regression problem. It didn't well practice, but later they go into a sliding window approach. That's what previous papers that we have put were based upon. And but the sliding window approach is not well suited for a deep convolutional neural network with large receptive fields and stride rates. So this is what they came up with another idea called regional proportion algorithms, based on another two papers which we will be seeing in the later part of the video. In that around 2000 category independent regions are proposed by that particular algorithms. Those proposal regions pixels are being extracted and they have made into a fixed size, and from that a conventional neural network extract enough features. That enough features are extracted, been put up into a class based SVM, linear SVM, to identify whether that category expected categories presented in that patch of image or not. So this is what this paper about, and this is what it is described in section 2. So three modules as mentioned earlier. First, it tries to go for region proposal. The second, we put a convolutional neural network, putting that particular region into a neuron and extract a pixel length vector. Then the third module is putting up a linear SVM for a category specific. So there are different regional proposition algorithms so far existed during that time, namely including objectness, selective search, category independent object proposal, constraint parametric min-cuts, multi-scale component variable group, and session. So these are other different set of methods for region propositions, but this paper utilized selective search methodology based on another paper which we will be introducing. This is the paper, not this paper, and this is the paper. So which we will be seeing in a later part of the video. And so this is what the selective search is about. Once the selective search is done, it selects a particular one, and that selected region may be of arbitrary size and scale, and that is made into a fixed size of 227 cross 227 pixel size using a standardized methodology called warping. And from that it's straightforward that put a, like AlexNet put up that into a convolutional neural network to get the feature. That feature is again put up into a SVM trained for that parameters to identify whether to score high for regions where it belongs to particular category or not. So this is what this paper is about, and hopefully we'll see about that brief idea about the selective search procedure maybe in the possibly in the next video. Thank you.